Let's go over this question which you've been given. A vector A has a magnitude of 50 meters at 175 degrees. If we want to subtract vector A from another vector B so as to produce a resultant along the negative y-axis that has a magnitude of 30 meters, what must be the magnitude and direction of A? Alright, so firstly let's get to represent this question on the x or y plane. Here we have the x-axis and there we have the y-axis. And we've been told we've got vector A that has a magnitude of 50 meters at 175 degrees. Now in which quadrant do we expect to find 175? We know this is 90 degrees, this is 180 degrees. Obviously the 175 should be what? In the second quadrant, right? Okay, so we're going to put this vector in the second quadrant and it should be so near to 180. Okay, so this is our vector A. Now we've been told if we want to subtract vector A from another vector B, we are going to produce a magnitude of 30 meters, and that vector that we are going to have is going to be along the negative y-axis. In other words, the resultant that we want to produce should be along the negative y-axis. Where is the negative y-axis? It's here. Okay, so that's where our vector is. That will be the resultant. Now what we want to find is a vector B which we are able to subtract from. So what I'm going to do is I'm going to break first this into components. So we have got, I'm going to put vector here, I'm going to put x component, and I'm going to put the y component. The first one with vector A. Okay, the x component of vector A is going to be given as ax being equal to a cos theta. The y component, that is ay, is going to be a sin theta. Now the x component, a itself, has a magnitude of 30 cos the angle related from the positive x-axis in the anti-clockwise to where the vector is, that is 175. So same here, that to be 30, but it is sine of 175. So all we are going to do is get to punch what we have there on our calculators. 30 cos 175, that is given me negative 29.88584. So we need to make sure that we get to use at least a lot of decimal points instead of getting to round off so quickly. If we say 30 sin 175, that is going to give us about 2.61467 Alright, and then we have got also vector B, but we don't know its x component. We also don't know its y component, right? We also have the resultant. But how did we find the resultant? That's the question that we need to understand. How did we find the resultant? So as to produce, if we look at this statement, so as to produce a resultant along the negative y-axis. Now, if we want to subtract vector A from vector B, so we are removing A from B, meaning that the x component of B, okay, we are saying B minus A because we are removing A from B. Therefore, the x components we are going to subtract them, right? And also the y components we are subtracting them. So this is going to be bx minus ax. And then for the y components also by minus ay. Now, what is the x component of b? We don't know that. Now, we know this resultant, okay? We know that the resultant is along the negative y-axis. Whenever something is along the negative y-axis, the angle that it makes is 200 and what? And 70. So to find the x component of the resultant x component is going to be equal to what? The resultant itself, cos theta. And then the resultant y component is going to be the resultant sin theta. So this is going to be the resultant itself is 30, and then cos 270 is the angle, and then this side is going to be 30 sin 270. Now 30 cos 270, Okay, if you just know cos 270 itself is a 0, so the x component, and that is rational because you shouldn't expect to have an x component for this vector because it's along the y. So this is going to be 0. Sin 270 is a negative 1 times that, that is going to be negative 30. All right. So now that we found this, we know that for us to get this resultant, what are we doing? It is bx minus ax, but we don't know bx. We know what ax is. What is ax? We found there that was negative 29.88584, and this should be equal to the resultant in the x, which is 0. Okay, so this negative and this negative, they're going to give us a positive, and then for me still to remain with a bx, I have to take this positive value the other side, so it still becomes negative 29.88584. And then we go to the y components. Also to the y components, we know that if we subtract by minus ay, but what is ay? Ay we found as 2.614672228. This should give us the resultant in the y, right? A resultant in the y, and that is what? Negative 30. So for me to remain with by, I'll have to take this term the other side. So it is going to be positive. So what I'm going to do is negative 30, it becomes a positive 2.614672228, and that is going to give us about negative 27.3852772. All right, so we have found the components of the vector b that we are supposed to subtract from the vector a. Now that we know the components, we should now find the magnitude and the direction. So to find b itself, b is given by bx squared plus by squared, and then we get to square root that. So that is going to give us square root of bx, that is about negative 29.88584 squared, and then by is negative 27.3, that is a 38.527. We can finish the other values. We also get to square that. So now we punch this on our calculators. All right, so the negative 27.385532772, we get to square it, and then plus the negative 29.88, okay, 0.88584, we also get to square it. The answer that we get, now we get to square root that. So we're going to find about 40.535. This is going to be in meters because that's the magnitude, the unit we are giving for this question. Now to find the direction, the first thing is we need to know in which quadrant this vector b is going to be. Now look at this. The x value is negative. Okay, the y value is also negative. In which quadrant we expect both the x value and the y value to be negative? That is in the third quadrant. So this is where the vector b is going to be. All right, so let's find the angle. We know that the angle is always given by tan inverse of y divided by x. So this is going to be tan inverse. The y component in this one, you can see that is a negative 27.3852772. The x component is negative 29.88584. All right, so we get to punch this. That will be tan inverse. So the negatives are going to cancel. That is going to be 27.3852772 divided by 29.88584. So this is given me 42.499. So this one we can take it just as 42.5. Right. Now, the angle that you find after punching tangent inverse on our calculators is always related to the x-axis, meaning that the angle that you found is this one here. If this vector was in this quadrant, the angle would have found is this one, always the one related to the x-axis. If the vector was in the second quadrant, the angle would have found is here. If the vector was here, the angle would have found is this one. So always related to the x-axis. So that means this is the 42.5 that you found. But when you are giving angles, always give them relative from the positive x-axis in the anti-clockwise direction. So the angle that we want is this one. So we know that this one is already a straight line, that is 180, and now we found 42.5. So to 42.5 just add 180, right? That is going to give us the value that we want. So plus 180. So that gives us 222.5 degrees, and that is the answer.